During a pandemic, every second counts. Millions of tests are needed, but testing everyone individually is slow, expensive, and wastes resources. What if there was another approach? Turns out there is, and it's called group testing. Normally, testing is done one by one. If a population has 1,000 people, that means 1,000 tests. But in many cases, only a small fraction of people in the population might actually be sick, but we still have to test everyone in order to hone in to where the disease is as quick as possible. Here's how group testing works instead. We combine samples from several people into one test. And if the combined sample is negative, that's great. Everyone in the group is healthy and we found out in just one test. But if it's positive, then we test smaller subgroups to find out who specifically is infected. This idea was first introduced by Robert Dorfman in 1943 to test soldiers for syphilis during World War II. Suppose that we need to test a population of 15 people. Rather than doing the 15 tests, suppose that we combine 5 people's samples together at a time for a total of 3 combined tests. And suppose one of these tests came out positive and the rest are negative. We can then further test the 5 people individually within this positive pooled test. The total number of tests we then use is 3 in the first stage and 5 in the second stage, which is 8, and that's 46.7% less than if we would have used individual testing and would have had to use 15 tests. This process is known as Dorfman's two-stage pooling algorithm. We're basically grouping different people together for our first stage of testing and then following up individually for the second stage as needed. The key here is to finding the right group size. If the group size is too big, then most of the combined samples are going to be positive anyways and you'll have to retest everybody. But if it's too small, you're kind of back to square one where you're testing everyone individually. So the key factor here is the number of people in your population, your group size, and the prevalence of the disease in the population. STEM is very exciting because you can use interdisciplinary fields to really start to understand this phenomena better. We can use mathematical analysis, just a little bit of related rates from calculus, to make a general formula for the expected number of tests per individual based on the prevalence of a disease in a population. Epidemiologists can also predict the prevalence of certain populations, say the people at your school or in your office environment. This is where modern technologies like predictive modeling and machine learning really come into play. By using computational thinking to approach pandemic testing, we have the potential to revolutionize the access to testing and save millions of lives. I sure hope there's no next big pandemic, but you might find yourself in a little group testing here or there.